What if I told you the next big revolution in AI didn't come from a computer lab, but from the mind of Albert Einstein? Today, we're diving into a wild idea that connects the shape of our universe to the words in our head. It's a breakthrough that could make AI way faster, cheaper, and honestly, a whole lot smarter for all of us. So let's just start with the one question that frames this entire story. What if the key to truly unlocking AI's potential isn't about cramming in more and more data, but about finding a better, smarter shape to put it all in? All right, to really get the solution, you first have to understand the problem. And right now, the AI industry has a huge, expensive problem that all comes down to how machines understand something we do every day: language.
Okay, here's the deal. For an AI to make sense of a sentence, it has to turn it into a string of numbers, a semantic vector. Think of it like a coordinate on a giant map of meaning. The problem? Right now, it takes 768 numbers to pin down the location of just one sentence. Now multiply that by the billions of sentences on the internet, and you suddenly have a data problem so massive, so expensive, that only a handful of tech giants can even afford to play the game.
To really picture this, let's use a great analogy. Imagine you have this Christmas tree. It's got this beautiful, complex, branching shape, right? And you need to pack it away.
Well, you've got two really bad options. You can buy a comically huge square box that the tree can fit inside, but you're wasting a ton of empty space. Or you can just chop up the tree, destroying the very thing you wanted to save. For years, the AI industry chose option one. They built a giant, wasteful box.
This quote just nails it. That fancy term, Euclidean space, is just the math name for the normal, flat world of a square box. Those 768 numbers we talked about, they're the dimensions of that giant, inefficient box. We've been trying to shove the branching, tree-like shape of language into a container that just doesn't fit. So how do you fix a problem that fundamental? Well, you might need to look for an answer in a place nobody else is looking. In this case, the theory of relativity. Einstein's big idea was that gravity isn't some invisible rope pulling things together. It's that massive objects actually bend and curve the fabric of space, and that curve tells other objects how to move. So, what if language worked the same way? What if the meaning of words could actually tell meaning space how to curve, and that curved space could then organize language in a much more natural way? And this leads us to the big aha moment. Instead of building a bigger box for our Christmas tree, what if we could design a box that was already shaped exactly like a tree?
And that's where something called hyperbolic space comes in. Now, it's a bit of a mind-bending concept, I know, but the key idea is actually pretty simple. Unlike the flat, grid-like space we live in, hyperbolic space expands exponentially. It gets bigger, faster, the further out you go. It's like having an infinite amount of room packed into a finite area.
Let's just put them side by side. Normal space grows evenly, like a grid. But hyperbolic space, it just explodes outwards. There's way, way more room at the edges than there is near the center. And that makes it the absolute perfect container for anything with a branching structure, like a tree. Or, as it turns out, like language.
So why is this such a good match? Well, because language is a tree. We naturally organize ideas in hierarchies. You start with a big, broad concept like animal. That branches out into categories like dog. And that branches out even further into specific types, like lab, pug, or poodle. It's an exponential structure. It's a perfect match for the shape of hyperbolic space.
Okay, so this is a really beautiful theory, right? But the real question is, does it actually work when you apply it? Well, the results are... honestly, they're kind of nuts.
First thing you'd worry about is quality. If you squeeze all this information down, do you lose the meaning? The answer is no. You retain 97.4% of the semantic quality. Basically, almost no intelligence is lost.
And what about the size? Get this. This new approach made the vector size 24 times smaller. We went from that clunky 768 number box all the way down to a super efficient 32 numbers. And here's the number that changes everything. Making the data 24 times smaller translates to a 95% reduction in the cost to run the AI. That's not just an improvement. That is a completely different ballgame.
So here's the bottom line, all in one place. Before, you had 768 dimensions, which meant huge costs, massive files, and slower speeds. After, in just 32 dimensions of this new space, the cost craters, the size is tiny, and the speed is up to 25 times faster. Just incredible. But this discovery is about so much more than just making AI cheaper. It points to something deeper, a fundamental link between the shape of space and intelligence itself.
See, it turns out that any complex system, whether it's a brain or a galaxy, has to balance three big jobs. It has to stay together, it has to stay diverse, and all the different parts have to stay in sync. And this new geometric approach gives us a fascinating look at that last one, staying in sync.
Take this idea of coherence. It helps solve a huge mystery in neuroscience called the binding problem. How does your brain just know that in the sentence, the black cat sleeps on the red couch, the blackness belongs to the cat and the redness belongs to the couch? Well, in this new AI model, the geometry does the heavy lifting. Black and cat are related ideas, so they get placed very close to each other in this curved space. Their proximity is the connection. The shape of the space itself automatically binds the right ideas together. Okay, this is all fascinating stuff. But let's bring it back to the real world. What does a breakthrough like this actually mean for all of us? In a word, democratization. When you slash costs by 95%, make search 25 times faster, and create AI models so small they can run on your phone offline, well, this tech is no longer just for the big guys. The source material puts it perfectly. The landlord era of AI is coming to an end. Now, a small startup can afford to build their dream app. A farmer can use AI on their phone in a field with no signal. A small-town hospital can run powerful analysis on its own records. It empowers everyone. And that brings us full circle. For years, everyone was hunting for the holy grail of AI, assuming it had to be a bigger model. But it turns out the answer wasn't a bigger model at all. It was a smaller, smarter space. It really makes you wonder, what's the next great leap forward going to be? Could the ancient science of geometry really be the key to our intelligent future?